Hey, Nicholas JMV here for our third video on net change as an integral of a rate. Today we're going to be looking at total versus marginal cost. Okay, so let's go ahead and look at the setup of this. So the cost function we're going to be calling C of x. C prime of x is going to be what's called the marginal cost. Okay, and C of B minus C of A is going to be the net change. It's the cost of increasing production from A to B. Okay, so here's the integral from A to B, or time interval of C prime of x dx. So that's what we're looking at integrating here. And we know the amount to increase production from A to B is called the net change. Here's our net change. Okay, so I've got one example to show you on marginal cost. The marginal cost of producing X computer chips in units of 1,000 is C prime of X equals 300X squared minus 4,000X plus 40,000. And that's dollars per 1,000 chips. Okay, so part A, find the cost of increasing production from 10,000 to 15,000 chips. Okay, in part B, determine the cost of producing 15,000 chips, assuming that it costs $30,000 to set up the manufacturing run. That is, the initial cost is 30 grand. Okay, so let's look at part A. Find the cost of increasing production. So the idea here is we're going from 10,000 chips to 15,000 chips. Okay, and we're going to go ahead and integrate our cost. Our C prime of X function, our marginal cost, is going to be 300X squared minus 4,000X plus 40,000. Might be good to use math 9 on this. We're going dx here. Okay, so here's our function setup. Okay, if we were going to integrate that, this now becomes 100x cubed minus 2,000x squared plus 40,000x. Now, unfortunately, we got to plug both these numbers in because one of them is not zero. We're starting at going from 10,000 chips to 15,000 chips. So what's that net change in price or cost for us? And if we plug in 15,000, we end up getting 487,000. We're going to subtract off when we plug 10,000 into this, which is 300,000. Okay, and that gives us a total of $187,500. Okay, so that's going to be the cost to increase production by 5,000 chips. That's the cost it's going to be. So let's look at part B now. Determine the total cost of producing these 15,000 chips. So in part A, we found how much it was going to cost to increase from 10 to 15,000, but we want to know the total cost. Okay, so the total cost, meaning if we go from C is 15,000 chips minus the initial amount, that integral, we're going to be going from 0 chips to 15,000 chips. Okay, and we're going to be integrating our marginal cost equation. So 300x squared minus 4,000x plus 40,000 dx. Make sure we got all that. Okay, so there's our integral setup. Okay, and we already know the integral of that. It's 100x cubed minus 2,000x squared plus 40,000x. Each of these terms has an x in it, so we don't have to plug in the 0. We're going to evaluate that from 0 to 15,000. Okay, so this is what we get. We get $487,500. Okay, but you got to be careful here. The initial cost needs to be added to that. So you're going to have the cost of the 15,000 is going to be equal to the initial cost, okay, plus that $487,000, $487,500. And so the actual total of this is $517,500 because you found out the cost from 0 to 15, what's it? The marginal cost to produce all of that was $487,000. But don't forget the startup fee, which was $30,000. So that's where you add $30,000 to that $487,500, and you get this. Okay, so that's an example of marginal cost and its relation to net change, or the net change and integrals. So if you have any questions or comments about this example that I gave you, go ahead and type them below, and we'll see you next time.